Welcome to the lecture on payback period. So, in the financial terms or in general terms also, payback period means something, a period in which the investment is supposed to pay back. So, many a times we use the terms like this investment will play in itself, and in less than suppose 3 years or 4 years, it means it will pay back whatever you have invested. If it goes for 4 years, and depending upon what is the cash flow at different times. So, there is a period in which it is supposed that whatever you have invested, it has come back. So, so that is what the payback period is, and we should know, because it is the most popular method used by the industry for assessing economic desirability of an investment. So, whenever any investor invests any amount, then he is interested to know that for how long he is once he starts the business, once he starts gaining something from it. So, how long he has to continue with a certain type of flow pattern, cash flow pattern, that his there will be payback so for the investment, and that period is normally known as the payback period. It may be calculated with or without interest. So, certainly when you have the without interest cases, then in that case your calculation method will be different. You do not have to see the time value of the money, and when certainly there is interest factor to be taken into account, in that case the payback period will be certainly different than that being found using the case without interest. So, when we talk about the payback period without interest, it is the length of time which is required to cover the first cost of the investment from net cash flow produced by the investment. So, that is what the definition says, that it will be the time when your first cost of the investment will be covered. Like you have invested 1 lakh rupees, and then you are getting for the subsequent years maybe 20,000 rupees each. So, when there is no interest to be taken into account, in that case in that case whenever this 1 lakh rupees is covered. So, if it is 20,000, in that case it will be 5 years. So, that we can see even by example, but before that so we should have some other more concepts. So, what is there, that if suppose f naught or f 0 is the first cost of investment. So, whatever you have invested, so that is your f 0, and f t is the net cash flow at in period t. So, net cash flow in period t. So, in that case what you do is that your payback period will be is smallest value of n that satisfies this following equation. So, that equation is summation t equal to 0 to n, and then this f t that should come greater than or equal to 0. So, that you will be finding that and whenever it is coming to 0, or in whatever time period, in whichever time time this f t becomes summation of f t becomes equal to or more than 0, in that minimum value of n will be known as the payback period. So, certainly we have to we are interested to find this n, and let us say for the case of for case without interest. So, when suppose you have case without interest, in that case it is very easy to see that how you to calculate this payback period. Suppose we can have one example, and suppose you have an example like end of year is given, and then you have different alternatives A, B and C. Now, suppose end of year will be 0, 1, 2, 3, 4, 5, 6. Now, let us say we know that in the year 0 your first investment is being put in by the investor. So, we have put in 1000 rupees, the investor has put in 1000 rupees. Now, this 1000 rupees is the investment amount by the investor, and you have three options, three alternatives. Now, payback period, payback which you are getting, or cash flow which is supposed to be to get from these three alternatives are like 500 in the first year, 300 in the second year, and then remaining 200. So, suppose this is the type of investment which this is the type of return which you are getting, or cash flow which you are getting from alternative A. Similarly, suppose for B it will be 200, 300 and 500, and then you have 1000, 2000 and 4000. And for C, suppose it is minus 300 and then 500 and 500, and then you have 0, 0 and 0. So, suppose this is a case without interest. Now, in this case if you see, you see that here you go to 3 periods, and when the interest is not taken, then simply you have to take the arithmetic sum of the FTs, and you see that at 3 it comes at 1000. Similarly, here also at 3 it comes 1000, and if you go to this for this particular investment this, then in that case suppose no, now in this case, in the case of C, it is 700 basically, not 1000, because 1000 will never be get, I mean we cannot obtain it. So, it is 700. In that case it will also be 3 years. So, in this case the payback period is payback period for all these 3 cases is 3 years. We cannot so with that there was a mistake in writing this 1000 to 700. So, this way now if says that will be the case whenever you don't have any interest factor into question. In that case you have to simply add these things, because there is no change in the value of the money, and that is why you have equal payback period for these 3 alternatives. Now, the thing is that this is the case when you have not considered the effect of interest. Now when you have now the thing is that although they are taking same time, but the thing is that the only difference what may be that on what rate you are recovering the amount. So, suppose in this case in the first year you are recovering half, and in the second year you are recovering 30%, and then you are 50%, then 30%, then 20%. So, you have recovered 80% after second year, and in this case you have recovered only 50% after second year, and in this case you have recovered only 20% after the second year. So, basically the only difference is that at what rate you are recovering, but otherwise the payback period in these 2 cases are basically same, and you can go for for this decision that how long the project should go, so that your investment amount is you are getting back to it to yourself. Now, we will deal with the situation when you have the payback with interest. So, that is what the normal case is when you are investing whenever some person is investing, he will try to and certainly the interest amount is into picture. So, in that case what you do is that you have to take that into account. So, payback with interest. Now, in this case you are, as you discussed, that you have to take the time value of money into account. So, to consider time value of money. Now, this is here also you have it will be same as the length of time, so it is length of time required until the investments equivalent receipt that will be exceeding the equivalent capital outlays. So, the meaning is that when there is there is advancement of time and you are getting different transactions, you are getting different receipts, then you have to see that what is the equivalent receipt and at what amount of time it is basically exceeding the equivalent capital outlay. So, that is what you have to see, and in that case what you go for the condition is that summation t equal to 0 to n prime and then f t and 1 plus I raised to the power minus t. So, that must be greater than 0. So, what it tells that whatever is the transaction, now this so f is already defined. Now, this amount must be greater than equal to 0. So, you are going to take all that from 0 time itself. So, the 0 time whatever you have invested, that will be a negative quantity, and later on the f1, f2 or f3, that will be positive, that may be negative. If it is negative, you have to take it as negative, and the sum of all that, whenever it exceeds 0 or it is equal to 0, that time we call it as the payback period. So, let us say if we calculate for the same problem which we have done. So, suppose we had we saw the investment A, where basically we are getting 500 in year 1, 300 in year 2 and 200 in year 3, and then further we had 200 in 4, 5 and 6. So, what way your payback period is going to differ. So, that can be calculated, and then in that case what you do is that you are calculating that value. So, if you have the end of year, as we discussed, that end of year you have 0, 1, 2, 3, 4, 5, 6, and for alternative A it will be minus of 1000 and then 500, 300 and 200 further for the 4 years. Now, in this case if you see the values, what happens that if you find the value, it will be going like minus 1000. So, this is the present, so it will be f t into 1 plus I minus t. So, it is 0 times, so it will be 0. Then you have plus 500 into and if the rate of interest suppose is 15%. So, we are taking the rate of interest as 15% compounded annually. So, if the the internal rate of return is 15%, in that case it will be f by so it will be p by f and 15 and 1. So, it will be basically 1.15 raised to the power minus 1, and this factor is coming out to be 0.8696. So, that is what we are getting 0.8696. Then we are going to 300, and this will be multiplied with p by f 15.2, and this factor will be basically 1 plus 0.15 raised to the power minus 2, and that will be 0.7562. We can refer this from our table, that you have 15% table and p by f we are looking at 8696756 or 2, then 6575 578, and all these factors we are going to use. So, 0.7562. Then for the next 200 you have again p by f, and then you have this 15 and 3. So, 15 3 will be 0.6575. So, further you have 200 p by f 15 4, it will be 0.5718, and then 200 p by f 15 5, and this is 0.4972. So, these tables, from the table we can get these values. Now, what we see that if we calculate these values, you have to take all that 5 to get it this value more than or equal to 0. So, in the earlier case when we are dealing with without the interest case, in that case we were only confined up to this time t equal to 3. However, in this case now let us say if we try to see the approximate value, so it will be something like 434, and it will be something like maybe 226 or 227. So, 434 plus 227, it will be 6 and 61, then further it is around 130. So, it will be 790 only, then again it is only 115. So, again it is only something close to 905, and then it comes maybe about 98 or 99. So, that is how it all together, all these 5 factors is to be taken into account, then this value basically is becoming more than 0. So, it is coming close to 7 rupees, which is coming before that it is not coming near 0. So, it is not going more than 0. So, basically what we see that when we take these interest amount into picture, in that case the payback period will be changing. So, and under this case of financial transactions, we can say that the payback period is 5 years. So, if before payback period you are stopping, in that case you are not able to completely recover the investment amount. So, that is what the meaning of the payback with interest is. And if you calculate for alternative B and C both, now in those cases if you try to calculate, it will be for B it will be coming as maybe 4 years, and for C it will be, you will never be able to get it, because for B in the 4th year you are getting quite a good amount. So, what happens that you have 200 here. So, 200 will be something 170. So, for if you take the case of B, so if you take alternative B, so 2, 3 and 5. So, 200 will be here. So, it will be 173, then 300 will be here. So, it will be something like 227, and 500 will be here. So, it will be something like 328. And so, what you see that in 3 years it is coming only it will be 300, 400 plus 3, 728. So, in the next case you have 1000 rupees here. So, then you are getting something like 570. So, here itself in the 4 years you are getting the 1000 rupees, that is what the 1000 is coming here. So, they are going to cancel. So, that is why in the case of B it will be 4 years, whereas in the case of A it was 5 years. In the case of C, if you look at in C, you know that it is minus 300. So, it will be going something close to minus of 260, and then you have minus 300 and 500 and 500. So, for C, if you look at for C, it will be looking at minus 300. So, it will be minus of 260 plus it will be 500. So, 500 will be 378, and then it will be again 500. So, it will be 328. So, it is not going to get you it is not it is less than 1000. So, anyway, this C is we are not able to have the payback situation with alternative C, and that is how we can understand the situations of payback with interest. Now, we will see that how this payback of with interest can be further presented with the help of So, suppose you are paying back a certain amount, you take one example or you take one case where basically you have given one investment capital, you have invested capital P, and you are taking amount A. So, every year, so you are getting that. Now, how that amount is going to, how you are going to have the payback period calculated. So, you can have that payback period calculated by getting that using that function. So, what you can do is that suppose you have A which you are getting, which is some percentage of P. So, in that case where 0 is so percentage is 0 to 100. So, what you do is normally in that case you will get A as so we know that A by P. So, this will be A by P factor is there. So, P is to be multiplied with A by P I n, and A by P I n we know that it will be I into 1 plus I raised to the power n. So, n prime it will be the payback period divided by 1 plus I raised to the power n prime minus 1. So, that way we can have the value of the n prime being calculated for a particular rate of interest, and when a interest rate and n prime is changing. So, for different interest rate that n prime with changing n prime, how this you can have the calculation of this n prime for different interest rates that can be calculated, and that can be calculated with a particular type of curve which will tell you that how this payback will be achieved. So, a curve will be generated, and that curve will show like this. So, you will have a curve like that, and in that curve you have basically this is your interest rate I, and this is your payback. So, that is your n prime. Now, what happens that suppose you are dealing with a case and the A is basically 6.25% or maybe 6% of P. So, and there is no interest case. In that case we know that payback payback period will be 100 by 6. So, it will be something like 16.66. Then when the interest rate comes into picture, then that time will be changing, it will be going on increasing because the A amount is basically being fixed. So, what we do is that we take this graph. So, if you take suppose this is 1, 2, 3, 4, 5. So, you have 5, this is 10, and this is your 15, and this is your 20. So, suppose this way it goes. Now we know that when and I value also will be, it will be 1, then 2, so it will be 3, you know, have it has 6, then you have 9, 12 and 15, and so it is going like that. Now what we see is that when you do not take any interest, and if A is 0.06 p, in that case what you see is it will be something here, payback period will be here, it will be 16.66, and that basically goes like this. So this way, so this line is known as 0.06 p. So this way you know, the payback period will increase if your interest rate basically is increasing. So interest rate becoming 2, the payback in time will be going like increasing. So that way your payback period will be changing. Suppose you are taking 0.08 p. So for 0.08 p, you know, if A is 0.08 p, in that case your without payback, without interest, your, we know that n prime will be 100 by 8, that is your 12.5 years. So it will be 12.5 years, and it will be coming something close to here. So it will be 12.5, and then it will also move like this. So so what we see that if you go for, so it will be 0.08 p. Then you have if you take 0.10 p, it will start from 10 and it will move like this. Then you have so this will be 0.10 p, then you have 0.12 p. So it will be, if it is 0.12, it will be 8.33. So it will be something like here, and then it will also move like this. So it will be 0.12 p, like that. So basically there is you know for the annual recovery you know amount, there will be, this curve may be generated, which can tell us that with different interest rate how these payback periods are going to vary. And then you see that if you have interest as 20%, so no, A is 0.2 p, so it will be taking only 5 years. So 0.2 p graph will start from here, and then it will go like this. So it will be going like that, and this these graphs basically talk about the you know different points where you know how with the changing interest rate how the payback periods are basically changing. So this graph basically will be useful to find, because we have 3 you know variables. You have variables like you have one is variable is interest rate, then you have a variable as the life of the project, and then you have desired payback as percentage of investment. Now in this case what from this curve what is there, that if 2 of these you know variables, if they are you know fixed, in that case the third can be found out from you know these curves, where which is I guess for the I versus n prime, and that is how you calculate this you know payback period, and it will go from till bottom. Basically it may go, if suppose it is 0.40 p, so it will be 2.5. So it will start from here, and then later on it goes like this. So it is going to as 0.40 p. Similarly if it is you know 30 p, then it will be 3.33. so it will start from here, and then it will move like this. So it will be 0.3 p, you know. So that way if you know 2 of the things of these 3 things, in that case so you have 1, 2 and 3. So that way you can find the third one, and you can say that this will be basically the payback period, and you can estimate about it, and accordingly you can plan about the investment investment things. So, that is what about the payback period. So, in this lecture, thank you very much.